So one of the security options we have in SQL 2016 in Azure for Azure SQL databases is Always Encrypted. And what Always Encrypted lets us do, as the name implies, is the column data is always encrypted. We're going to look at other forms of security like TDE, Transparent Data Encryption. In TDE, the data is only encrypted at rest. It's not encrypted in transit. So this encrypts the data no matter how it comes and no matter how it goes out. The other advantage here with doing this is the keys are stored on the client. So what that means is that people that have access to the data volumes don't have access to this column data because they don't have the key to decrypt the contents of the column. So again, it encrypts the data both in transit and at rest, and the column, the keys that are used can be stored on the client. It can be configured for deterministic or randomized encryption. You have to be very careful here. Deterministic in SQL terms means that given the same set of circumstances, you'll always get the same result. Well, if you want to use this column in any join conditions or any comparisons or any where clauses in the future, you have to use the deterministic encryption option, because otherwise, if we use randomized, the value will change and it may not be the same each time. So when I compare it, I'm not going to ever get an equal value. So that's very important when you look at this option. We have two keys that are going to be used for this encryption. Just like we do in most things that do encrypted data in SQL Server, we have a master key. The master key is used to protect the column encryption key, which is used to encrypt the column data. In order for us to be able to do this, you have to have the .NET 4.6 framework, and you have to have one of the three supported drivers that are used with this. There's an ODBC driver, there's a JDBC driver, and there's the .NET driver. You also have to have SQL Server Management Studio 13.0.700.242. It's important to remember that you can download and install this version of the Management Studio for free, and you can run different versions of the SQL Management Studio side by side on the same machine. So another option we have to provide protection of data in a column is column level encryption. With column level encryption, which is also sometimes referred to as cell level encryption, we can enable encryption in the column. The difference between this option and the always encrypted option is this uses a symmetric key. The same key is used to encrypt and decrypt the data that is protected by the database master key. We can use this in Azure SQL Database, and it was actually implemented in Azure SQL Database to provide backward compatibility with a feature that was also available in on-premise SQL servers. It uses a certificate to store the key that's used for the encryption and the decryption. You have to make sure that the data can be decrypted by providing access to that key. That's very important. And we would implement this in Transact SQL by using the encrypt by key property to encrypt the column itself, and we've referenced the column with the encrypt by key option. So another option we have for protecting data is something called dynamic data masking. For those of you who may have worked in environments like Exchange, where they have this new concept called data loss prevention that prevents certain types of data from being sent or seen. Here we're talking about preventing certain types of data from being visible to most users. It's a column level property that we can implement, and we do it either by using the Azure portal for Azure SQL Database, or we can do it using the Azure PowerShell commands. It doesn't encrypt the data, all right, so it's still stored in its unencrypted format in the column, but when the data is retrieved, it's obfuscated. So it's hidden in a certain way, and it depends on which of the masks that you use as to how it will be obfuscated. So you'll notice for many of you that have done this stuff before, there's built-in options here that you have that are going to be what you'll see commonly things called data loss prevention setup. So credit card data, there's user number data. So in the default, if it's a number, it will only show 4 X's. If it's less than 4 digits, it will show however many X's there are for the number of digits. If it's character data, it will show I'm sorry, it'll show 4 X's for character data. If it's numbers, it'll show zeros, up to 4 zeros. Again, for things that are less than 4 digits, it'll only show that many digits. With the email option, it shows just the first letter of the email address. With the customer information, this is a custom string. This should be custom, not customer, right? So we have a custom string option. And the custom string option lets us specify a custom string. We specify a prefix, we specify a length, and then it automatically replaces data with that. We can do a random. The random depends on a range, so we define a range of numbers that it will use to show the data in. And with the credit card, it just shows the last 4 digits of the credit card. So what this lets us do is hide information from visibility. Now, by default, admins always have the ability to see the data unmasked. There's also when you set the masking up, the very last screen in the wizard is going to allow you to control which users can see the data unmasked. So you can define which users, SQL users that are excluded from the masking. That lets them see the data in an unmasked format. It's important to note this is not encryption. So this is done on the front end when the data is being pulled back out. They also mention in your text that you cannot implement data masking on top of always encrypted, right? So you have to pick one or the other. The two are not compatible with each other. So another option for securing our data inside SQL is TDE, or Transparent Data Encryption. Transparent Data Encryption has been around for a long time, and what it lets us do is encrypt the data at rest. And that's very important to understand here. It does not encrypt the data in transit. It only encrypts it in the database. And as they mentioned here, it also doesn't protect against unauthorized access, like the obfuscation or the data masking might do. This does not protect against people looking at the data. If they have permissions to the SQL server and to the SQL database, they will be able to see the data. What it does is it uses keys to encrypt the data. You have a master key, you have a service master key, you have a database master key that's used to provide the encryption for the data. When the data is accessed by an authorized individual, SQL Server automatically decrypts the data and presents the data to the user. Like things like BitLocker, what it would protect against is theft of the physical media. So if someone were to access the hard drive and pull the hard drive out and then try to attach that database to another server, they wouldn't be able to see the data in the database because they don't have the key that's used to decrypt the data. It provides for automatic key creation and automatic key rotation of the service master keys and the database master keys. However, you cannot store these keys in the Azure Key Vault. They have to be stored and managed by the SQL Server itself. It can be used in combination, however, with Always Encrypted. So the Always Encrypted is going to provide protection at the column level. This will provide encryption of the entire database. So we're actually encrypting the data in the column twice when we implement TDE in combination with Always Encrypted. So another protection mechanism that we can implement for our Azure SQL databases is the Azure Firewall rules. We've talked about this already. They're called network security groups, if you remember that from before. This allows us to control from which IP addresses connections are allowed to be made against either our Azure SQL database SQL server or against the individual database itself. So again, if I have multiple Azure databases that I've created in a single Azure SQL server, I can provide access to the server from one IP address, and they, again, permissions still being required, can see the databases and access the database, all the databases on that server, or I can do it on a per database basis. We do this configuration through the Azure portal, or we can do it through PowerShell, Azure PowerShell. We can do it for single IP addresses. We can do it for ranges of IP addresses. Just remember that in order to do this, you have to make sure that you know what your public IP address is. If you're using an on-premise environment that uses NAT servers or proxy servers, there are tools out on the web that can help you identify what your current IP address is. You'll do this in the upcoming lab and you'll get to see the process for setting these rules up. But this allows us to block or allow access to the Azure data, to the Azure SQL database data from specific IP addresses and specific locations within an organization. In this demonstration, we're going to look at how to enable Always Encrypted in Azure SQL Database. In this demonstration, we're going to look at how to enable the Always Encrypted option on a column, and then look at the data and how it's been encrypted, and then we're going to remove the Always Encrypted option on the column. Now we're going to do this in a database that's already been created in SQL Database. So I've already connected to my Azure SQL database. So here's my databases. So I have two databases in here. The AdventureWorks LT and the test PSDB that we did in a previous example. We're going to make use of the AdventureWorks LT. So we're going to expand the databases. And we're going to go ahead and create a new query window. Now we're still going to do some work before we actually run a query, but we want to make sure that the query window that we're running here is running on the AdventureWorks LT database. So that's been done. So now we're going to click on Security, and in Security we're going to look at the Always Encrypted keys. Now you'll notice right here we have column level master keys and we have column encryption keys. Let's expand this out a little bit so you can see it better. So column master keys and column encryption keys. The first thing we need to do is create a column master key. So we're going to click on the column master keys, create new column master key. We're going to call this CMK1 to indicate it's the first column master key. And we're going to store it in the Windows certificate store under the current user. And we're going to click Generate Certificate. And there's our new certificate that we have. And now that we have a master key, we're going to go ahead and create a column level encryption key. Apparently my SQL server is less than happy right this minute. Okay, so now we can put in a name for the column encryption key. CEK1 for column encryption key, and we'll select the master key that we have. That will be used to protect the encryption key. Now that we have the two keys that we need, we will go ahead and look at how to encrypt the data. Now the first thing we want to do is we want to look at the columns that we have in our tables. So we'll come over here to our tables for the AdventureWorks LT, and we are going to look at the sales LT address table. And so that's one of the tables that we have. And what we want to do is we want to just do a real, I'll do it this way, but they had me write a query, but we'll do it this way. We can select the top 1,000 rows. Apparently we seem to be having an internet connectivity problem. So we've received our results. This is all the results. There's 450 rows, and what you'll notice is the column data here. And we're going to focus on things like the postal code and the city columns in a little bit. So that's pretty much doing select star from the, and I can change this to the query that they had. So if we come in here and we say select star, that's the query that they had written. So what we're going to do is we're going to right click on the city column here. Let's click on city, we'll right click the city column. And we should have an option. Let's rerun this query. So now that we see that all the data that we have, we'll come down here to columns, and we'll click on our address, our city column right here, and we will encrypt this column. So that takes us through the wizard to do the encryption of a column. What we're going to do is we are going to go next on the introduction where it explains what we're doing. We've already selected the city column because that's how we started the wizard. Notice that we only have one encryption key for the column. So that's the encryption key that we will use to encrypt the data. Now in the encryption type here, we're going to use deterministic. And the reason we're going to use deterministic is because later when we write queries that want to look for things that match, if we don't have a deterministic query, it'll have a random value. And so you won't be able to do things like comparisons. Any columns that you're going to use in joins and things like that, you're going to need to make sure it's deterministic. And there's the message about the collation. It'll be changed from SQL Latin 1, let's get back over that, to bin 2, right? From CI, the bin is going to be binary. So it's going to change the column data type, or excuse me, the collation to binary collation. So we already have a master key. We don't need to do any configuration on that. So now we can tell it to proceed to the finish. We could generate a PowerShell script so that we could run this later on. And then we'll click Finish, and that will perform the encryption on the data that's in the city column. Okay, so you can see that our encryption worked. So now our column is encrypted. So now in our query, we will use AdventureWorks LT, and we will select star from sales LT address. Not sure why our connection got dropped, but we seem to be having some fun issues with our internet connectivity with Azure right at the moment. So as you can see, we now see that the city column and all the data in the city column is now encrypted. Now what we're going to see in a second is we've specified that this all be encrypted, but we're going to change this a little bit. We're going to add another query in here. I'm just going to cut and paste since things have been so fun. So we'll copy this. We'll come out of this window. We will paste in the query. And what you're seeing here is we're comparing values, right? And we're comparing data based on city. So we're doing count city, and we're doing it by region code. And we're comparing the city information. And if this was not deterministic, when we ran this, it would give us errors. There's a problem with the group by here. It would give us errors because it wouldn't be able to compare the data. Actually, it wouldn't return any values because it wouldn't be able to compare the data. What doesn't it like there? Oh, the from. Yeah, this is the problem with the cut and paste. It doesn't put in the carriage returns. So you can see, we can see the country, region, and the city count, and the city count values are actually the same because we used deterministic when we did the query. So now what we're going to do is we're going to look at the indexes. So we'll come over here to our indexes column, and we'll click on the index node, and we're going to specifically look at the address line index. And we are going to script this perhaps. So we're going to script this into as drop and create in a new query window. And the reason we're doing this is because the postal code column can't be encrypted when it's in this index. So we're going to drop the index. And then we're going to go in, now that it's not part of an index, we're going to go to the postal code column. And we're going to encrypt this column. Postal code. And this time we're going to do randomized. And so what we're going to see is when we do the randomized function, none of the values will be the same. So our encryption is completed on the postal code column, so we'll close this screen. And so now what we'll do is we'll select the data from the postal code column, and again you'll notice that this data is now encrypted. What you can't really tell easily, because there's so many rows, is that none of this data is the same. So it was randomized when it did it. So then when we run a query like select count star based on a column, we do a group by or a where or some type of function on the column, we're going to get an error, and it tells us that we can't do that because it has been encrypted with randomized type. If we want to do any comparisons on it, we have to do the encryption with deterministic. And somewhere at the end, it should tell you that it has to be deterministic. So that's where you have to decide what type of encryption you want to do. So now that the encryption has been enabled, we're going to go ahead and remove encryption. So again, we'll start with the postal code column. So we'll come over to our postal code column, and right here you have encrypt column, and it's kind of weird, there's no unencrypt option there, so we click next on the screen, and you'll see that postal code is already encrypted. So what we'll do is we will select here under the encryption type, we will select plain text, and that will unencrypt the column. And we will do it right now. We will click finish. So again, we seem to be having problems with our Azure connection. So you can see the error here is telling us it can't connect to Azure. So we're going to go ahead and move on with this. If we come over here to the address table and we tell it we want to script this as create to a new query window, what you're going to see in the query window is an option as part of the column name to say that it's going to be encrypted. So that's a way of identifying. And it'll also specify the algorithm that we're going to use. So you see right there, encrypted with column level encryption, and there's the key that we're going to use. So that's the process for encrypting and decrypting columns. Again, make sure you remember the difference between the randomization and the deterministic options based on the purpose of the column. In this demonstration, we got to see the process of how to enable always encrypted for a column in an Azure SQL database. We also got to see how to view that data in the Azure SQL database and view it in its encrypted format. So when we want to store data in the Azure environment, the first thing we have to do is set up an Azure Storage account. When we set up the Azure Storage account, we're going to define what type of storage it's going to hold. In the general storage options, we can define blob stores for unstructured data. If you remember earlier, we talked about using page blobs for some SQL data. We can do file general stores that's going to hold file shares. We can use queue storage for asynchronous operations that allow data to come in and then be acted on by something else as the data arrives, like Microsoft Message Queue services. We can also do NoSQL tables for NoSQL storage that allows us to store the data in an unstructured table storage connection. There's also blob stores which hold blob data. If you remember previously, we talked about the blob stores. The blob stores are used for virtual machine storage. So that will allow us to store the virtual machine VHDs. With the blob stores, there's hot access tiers and cold access tiers that have different pricing schemes associated with them. So if we decide to store information in Azure, there's some problems sometimes with using Azure Storage that you can't really see in a graphical way of what your data is there. So they created a tool that you can download and install called the Azure Storage Explorer. This allows us to view the storage information and then manage it from the Explorer. They mention here it's currently in preview model. I think it's out of preview by the time this video is going to be released to you, but just keep that in mind. Preview means they may make some major changes before they actually mark it as for production use. Once we download the Azure Storage Explorer, we can then connect to our Azure Storage in one of three ways. We can specify our Azure account, and this is going to be an account that has permissions to access the storage environment. We can use the shared access signature that we've created, and that will allow us to connect to the Azure Storage account. Or we could use the storage account name and the access key, either primary access key or secondary access key that's defined for the storage account, and use that to connect. Once we're connected to the Azure Storage environment, we can use this tool to view the data, copy it, copy data in, copy data out, download data from the environment, manage the data. You can even use it to delete the storage information and even delete the storage containers that have been created in your Azure Storage account. So if you remember previously, we talked about storage spaces and storage pools that we can create in the Windows Server environment. Well, if we look at Azure Services are actually running Windows servers, so we can use this feature inside of an Azure VM. With an Azure storage space, we can combine multiple disks from various locations. Now remember, we're talking about virtual environments. We're talking about Azure VMs. You're going to have data disks that you're going to be attaching, and we can have different types of data disks. We can have standard disks and we can have premium disks. Premium disks are going to be SSDs. Standard disks are going to be spinning hard drives. So we can combine multiple disks together into a storage space. We can then add the pool from those disks. We then can create a virtual disk from the pool, tell it which disks from the pool that we want to use, and then identify the tiers of the storage that we want them to have and associate specific connections to those appropriate tiers. Just like with an on-premise storage pool that we create, in an Azure environment, we use the server manager utility from the virtual machine to create our storage space, to create our storage pool, and to create our virtual disk and then format our virtual disk. So again, as mentioned previously, one of the big advantages to using storage pools is the ability for us to add disks that have different characteristics, specifically SSDs and HDDs, that allow us to identify faster, more efficient disks versus slower, less expensive disks. So what we can do is we can add multiple disks to a storage pool, some SSDs, some hard disks, some HDDs, and then identify them as separate tiers. Once we identify them as separate tiers, data is written to the HDD tier, and then when it's being used more frequently, it's moved from the hard disk drive tier to the solid state drive tier, because that's going to be a faster response time from those faster disks. If it's not being used frequently, it's then automatically moved back to the HDD tier. So they provide the performance enhancements while making inexpensive disks available for data that's not used frequently. We need to identify the tiers as either SSD or HDD, and you can do it through the server manager, but people oftentimes make mistakes doing that. They forget to identify it. The better option and the recommended option in your text is to use the PowerShell, and you use the media type parameter, and you specify either HDD or SSD to identify the faster and slower disk types for the tiers. In this demonstration, we're going to look at how to create a storage pool in Azure.
In this demonstration, we're going to see how to set up storage spaces in Azure. We're also going to look at how to create different media types, set different media types for the different storage objects that we've created, the virtual disks that we've created in Azure. And then we're going to look at how to set up tiered storage. Now, I've already logged into my Azure portal, so here's my Azure portal here. And what I'm going to do is I'm going to go to my resource groups. And so I'm going to expand this to see the resource group. The one we want to use is the one we created. I created using a script that's available. And the resource group name is Storage Spaces Demo, which I do not see my resource group. Well, we'll just click there. That'll show us the Storage Spaces Demo resource group. And there's the objects that exist within the Storage Spaces Demo resource group. And you have a virtual machine here, so that's VM1. That'll take us to the VM1 properties blade. And in the properties blade, we'll be able to figure out, we'll be able to connect to it. So we'll go ahead and connect. And we'll go ahead and open that RDP connection. Connect. And our password is entered, and that's just going to open up a remote desktop connection to our virtual machine VM1. And what we're going to do in this connection is we're going to go ahead and add in the disks that we created previously into a storage pool. So we created, there was a script. Let me show you what the script does. There's a lot of steps in the script, not in the VM build. So there's a lot of steps in the script. So if you look here, there was a series of components here that created, if we open this with Notepad instead of, so right down in here you're going to see it creates a bunch of disks. So that's what this does to get started. So see this right here, creates 1, 2, 3, 4 disks. One is a P1. Eventually it's going to become a P1. The others are standard disks. So we have 4 disks that we've created in the Azure tenant that we're going to then now add to our virtual machine. So in the virtual machine, we're going to go to the file and storage spaces. We're going to click on storage pools. We're going to click on the Primordial pool, which is here. And here's the other disks that we now have. You can see the physical disks that are listed here. Those are going to be the ones that we're going to add to this pool. So in the Primordial pool, under tasks, we're going to click new storage pool. Right here, new storage pool. Now this gets a little bit weird because the start menu screen gets in the way. The taskbar gets in the way. What happened to our wizard? There it is. Oh, sorry. This is what happens in a lot of VM type environments. So here's the screen we want. We have to drag it up to get to the next box. So we click next there. For the name of the storage pool, we are going to call it My Storage Pool. Let's pick something better in real life. We're going to specify it as part of the VM Primordial pool for VM1. We're going to select all the disks. So if you check the box at the top, that'll select them all. That's going to add these 4 disks to the pool. We will go ahead and say create, and that'll create our storage pool and include those 4 disks in the pool. Now, once this process is complete, if we scroll up here to the storage pools, there's my storage pool, and if we click on it, we can see we have 4 disks in the pool. So now what we're going to do is we're going to set, you'll see that the media type for the pools, for the disks in the pool, is listed as unknown for the media type. So we're going to set the media type here using PowerShell, and what that's going to do is it's going to allow us to create tiered storage. So we'll minimize the server manager. We'll open up PowerShell. We have a PowerShell script created for this. That's the reason we're going to use the PowerShell here. So we're going to open up the PowerShell ISE as administrator. Let's run as administrator. So what we're going to do is we're going to open up a script file that we have that's already been created for the class environment. But it's actually on the host machine. So we'll minimize this right here. We'll go to the host machine. We'll go to the D drive. We will go to our demo files, module 10, demo, change media type, copy, bring up our RDP session again, go to the file explorer. I'll just put it in the documents folder, paste. That'll put our script in there, close that. Your documents, change media type, open. So what this is going to do is it's going to have a script in here that's going to automatically change the type of the documents. Let's scroll this down a little bit, and you can see right here, this gets the media information, so it lists the physical disks, and then the script down here will actually change them. So what we're going to do is we're going to first list the physical disks. So this right here will get a list of our physical disks, and we'll run that selection. And there's the output. And if we scroll, you can see the unique IDs. These are going to have to be copied in to the different disks. I'm going to pause the video while I copy the unique IDs in. You don't need to see that process. Okay, so you can see I've copied in the IDs into each of the variables. So we're going to go ahead and initialize these variables and set the values. And now we're going to go ahead and set the media types. And what we're going to do is we're going to set LUN1 as premium storage, and it's going to be SSD, and the others are going to be spinning or rotating hard disks, which are going to be standard storage. So now that I've set that, and I've set the components of it, we can come back up to run this script again to get the physical media types. And when we run this, what you will see is, see under media type now, we have different types. So SSD for LUN1, everything else is going to say HDD. So we'll bring back up the server manager, and we will now refresh the storage pool environment. So we'll refresh there. And again, notice how all of the media types have changed in the media type column. So now what we're going to do is on the virtual disks, we are going to create a new virtual disk that's going to be used by the server, the virtual server, using the storage pool that we created. So this virtual disk we're going to call my virtual disk. Again, in real life, let's make it something more useful. Now notice we check the box, create storage tiers for this disk. We're not going to do resiliency for this, so we're going to do a simple volume. We're going to use fixed provisioning. And then if you look, the faster tier, we're going to specify the size of the faster tier as 85 gigabytes. And the standard tier we're going to specify as 180 gigabytes. And then we click Create. Now, we will then create a volume off of the disk that was just created. So again, we need to move this up a little bit. Click Next. It's going to be for VM1. It's going to be my virtual disk that we're going to use. We're going to take the size of the combined components that we did before. We're going to assign the default drive letter that's going to come with it, which is going to be F, the next drive letter in the list. We're going to format it with NTFS. We're going to click Create, and that's going to create our volume. So the process here is you attach the disks that you want, and so because we're talking about Azure, you go into Azure, you create virtual disks, you attach those disks to the VM. Once they're attached to the VM, you then go ahead and create your storage pool, and then once you create your storage pool, you set your media types, and then once you set your media types, you create a virtual disk, and then a volume on that virtual disk.
In this demonstration, we got to see the process for how to create a storage pool. We also got to see how to create a virtual disk and how to enable tiered storage in Azure. So one of the things Microsoft is trying to do is take a lot of the tools and resources that we can use in an on-premise environment and make those tools and resources available in the cloud in Azure. And to that end, they've given us this thing called Azure Automation. Now, for those of you that might be familiar with System Center Orchestrator, this is a similar concept. And what it allows us to do is to create automation processes or automation tasks, or as they're going to mention here, runbooks, that will automatically run in response to something that's occurring, and then it will carry out the operations of that runbook. Now, if you were to look at Orchestrator, with Orchestrator, there's these things called integration packs that allow you to connect to lots of various different environments. We don't quite have that yet. It's coming. It's just going to take a little bit longer to get here. For right now, the only automation tasks that we have are PowerShell scripts. Now, there's a bunch of automation tasks already created that will let us do things in SQL databases, Azure Storage, Azure Virtual Machines, cloud services, websites, backups for Azure Virtual Machines. In the Azure SQL database, we can do Azure backups for SQL. In order to do this, the first thing we have to do is set up an Azure Automation account. That's going to be an account that creates objects and manages the objects for us. After we create the automation account, the runbooks are then created as our workflows that are going to create the process of things that are going to be carried out based on either a schedule or based on functions or things that occur within the environment. There's a bunch of sample runbooks that we have in the runbook gallery that we can add, and when you add them, you're actually publishing them. When you publish them to your environment, to your automation account, it makes them available to be run based on your automation account. And this lets us carry out automatic activities that are going to occur on our Azure virtual machines or on objects within our Azure subscription that we would normally do on an on-premise environment using tools like System Center Orchestrator. So when we start to work with Azure environments, just like a lot of on-premise environments, we may be doing a lot of things in PowerShell. Now, SQL is one of those environments that, yes, it does provide support for PowerShell, and it does have a PowerShell module, But an on-premise SQL environment, SQL has its own language, Transact SQL, and we generally do things using Transact SQL as opposed to using PowerShell. That being said, we can do some things through PowerShell. When you start to look at things like Azure and even products like Exchange and SharePoint, a lot of things can only be done through PowerShell. So with PowerShell, it's a scripting language, and it's designed, for most people's agree that it's designed essentially to allow admins to do scripting without having to learn a scripting language, like VB scripting. It has commandlets, sometimes referred to as just commands. There are aliases for these commands. Examples would be things like dir, would be an alias for get child item. There's ls, which is also an alias for get child item. So the aliases allow us to create shortcuts to commands so we don't have to type out the entire command. There are going to be parameters that are going to be available for most commands. The thing to understand about the PowerShell environment and commands and commandlets is you don't get to control how they work. You don't get to control what the parameters are. That was defined by whoever created the commandlet and compiled the data for that commandlet. The commandlets are grouped together in modules based on what types of objects they're going to manage. So there's modules for, as I already mentioned, SQL. There's a SQL PowerShell module. There's an Exchange management shell. There's a SharePoint management shell. There's an Active Directory module. Sometimes you'll see older versions of this were listed as snap-ins. They'll be called snap-ins. If I wanted to use PowerShell, for example, Azure PowerShell, to create an Azure SQL database, these are the steps that I would use. First, I would say add Azure RM account, and I'd put in my credentials. It would prompt me for my Azure credentials. After I put in my Azure credentials, I would say log in Azure RM account, and I would log into that environment. That is going to then let me select my subscription ID that I want the objects that I'm about to create to be associated with. I would then say new Azure RM resource group. And remember, resource groups in Azure are a container that hold all objects that are used for a specific function or service or component. I would then get the resource provider to make sure that I was connected to the Azure subscription that I wanted to. Then I would use new Azure RM SQL Server to create a SQL Server in Azure. I would then use new Azure RM SQL Server Firewall rule to grant connections to that SQL Server from my local IP address. Now it's important to note, before I started this, I would have needed to get my local IP address that's on the internet. And then I would use the new Azure RM SQL database to create an Azure SQL database. When you do the new Azure SQL database, it's going to ask you for credentials that are going to be created as the DBO for that database to manage all the objects within that database. And so this is a series. Now, I could put this all in one script file and run the script file, and then it would go through the steps in order for me. I could pre-create the values that it's going to ask me for, like the SQL Server name, the resource group name, the login credentials, and I could put those in variables so that when I run the script, it automatically puts those values in and it doesn't prompt me, and it can run silently for that process, so I can automate it. And that's really where this becomes useful. I can now automate administrative activities without having to walk through the wizards and the components every single time I want to carry out that task. So now that you have a good understanding of how the PowerShell environment works and how the automation account works, once we have an automation account created, we can then go into the Runbook gallery and look for automation tasks that will automatically do things for us based on conditions that we define. In the Runbook gallery, there's a bunch of scripts, PowerShell scripts, PowerShell workflows, and graphical runbooks that allow us to carry out certain functions or certain administrative tasks within our environment. There are two types of runbooks in the Runbook gallery. There are Microsoft scripts that have been reviewed and tested by Microsoft, and they're pretty much guaranteed to work as written. There are community contributed runbooks. Anybody can write a runbook and contribute it. Those are not necessarily tested So keep that in mind. You're going to want to, if you're going to get a community runbook, you're going to want to test it. You want to look at it before you put it into production environments. Once you get the environment and the runbook that you want, you import that runbook into your Azure Automation account, and then you can edit that runbook to suit your needs. You can customize it. You can put in variable assignments. You can put in details about your object names and things of that nature, and then you can publish it to make it available to run in your environment. In this demonstration, we're going to look at Azure Automation.
In this demonstration, we're going to take a quick look at Azure Automation. We're going to look at how to create an Azure Automation account. Then we're going to look at the Runbook gallery and some of the automation components that have been pre-created for you. And then we're going to import one of those runbooks and edit that runbook to show how it works. So the first thing we have to do is log into our Azure tenant. I've already done that. You can see right here, this is our Azure tenant. And then we're going to create a new, and in the new categories, we're going to click on monitoring. So now we have a new environment. So we'll click on new, add a resource. We will click on monitoring and management, and in monitoring and management we have automation. So the first thing we have to do with the automation objects is we have to add an automation account. For those who might be familiar with things like System Center Operations Manager and products like that, we're essentially creating a run as account here. So we'll give it a name, automate Bill W, right? And this is going to be in our Azure pass, and we will use an existing storage spaces demo. I'll just stick it in the storage spaces demo resource group, just so I can dump it all at once. So we will pick all the other objects in this resource group are in East US. So we're going to try to find East US, which you would think that this would be in East US does not support automation yet, so we have to pick East US 2. So we want to create the Azure Run As account, and we hit create, and that's going to create our Run As account. So again, it's in other versions, it's called a Run As account. Here we call it an automation account, but it serves the same purpose. So if we look, there's our Automate BW, that's our automation account. And we're going to use that to access and do the process of running functions and running components. Still creating it. So now we'll click on the automation account, and that'll bring us to the ability to see the runbooks. So that lets us see the runbooks. So if we click on runbooks, you're going to see there's 4 runbooks that are automatically published, and these are just test runbooks that we can play around with. So if we go back and we say browse the gallery, this will let us see a bunch of different types of runbooks that are available. And you can see, right, stop Azure VMs, start Azure VMs, do backups. Notice a lot of these have to do with virtual machines, but there's a vertically scale on Azure SQL Server. There's identify the tenant information for an Azure tenant. So what we're going to do is we're going to look specifically for publisher. So we have graphical runbooks, we have PowerShell runbooks. So you can see right here, these are the different types that we're doing. These are all PowerShell runbooks. You can see that from the PowerShell icon right here. So if I turn off PowerShell script, right, click OK, notice how there's nothing left in the publishers, right? So we're going to change the filter and put the PowerShell scripts back in. There's also PowerShell workflows that we can use. So we'll click that back in there. So we don't see what we wanted, so let's go to hello, and there's a hello world for Azure Automation. That's the one that we want. There's a graphical version of it that we can see how it's laid out. For those of you that may have some experience with System Center Orchestrator, these runbooks are based on that. So we're going to click the Hello World Azure Automation PowerShell Workflow Runbook, and we're going to import that. The runbook type is already set, so we click OK to import that into our Azure Automation. And then right here we can edit the code for this, and you'll be able to see how it runs. So for those of you that might know how help files work in PowerShell, that's pretty much the help file synopsis there. So this is going to write hello world. And you can see we could edit this and modify it however we needed. And so what we're going to do is we're going to change this, and we're going to change it to say right here where it says world. We're going to change that, and we're just going to put in Bill Wood. So we're going to save that change to the runbook. We're going to publish the runbook to make it available. And now that our runbook has been published, we're going to start it. It's going to run PowerShell. We'll just click OK for the default name. So you can see the runbook's been submitted. And if you look at the output, the runbook is currently running. And what we should get to see, is it should say, hello, Bill Wood. And you can see it's still in a running state. So the point of this is you can then take these types of automation jobs, define things that have to be done on your virtual machine environments. Like, for example, this would be a way for you to create automation for SQL Server, Azure SQL databases to automate transact SQL scripts in Azure SQL databases. So there it is. See, hello, Bill Wood. So there's the output from the Azure Automation job.
In this demonstration, you got to see the process for how to create an Azure Automation account, how to import an Azure runbook from the gallery, and then how to edit that runbook. In this lab, you're going to implement a couple of features for managing databases in the cloud. First, from the security part, you're going to implement data masking for a column in a database that's in Azure. Then you're going to implement Azure Automation. You're going to import an Azure Automation runbook that is used to stop virtual machines. This lab is going to take about 45 minutes.